Hey guys, it's Mr. Sanborn here, just getting set up with some new software for video recording, so bear with me as I kind of get this thing going. This is video lesson 1. My goal today is to just speed through the basics of a platformer because some students have sort of expressed uncertainty about what they're supposed to be doing here. So as you can see, I've got my Unity window open. To save time, I've already grabbed my images for the platform, the background, and a sprite sheet. Those are all things you can find online. As you hopefully recall, you can open up paint.net to clear the backgrounds of those and put them in PNG form so that we can use them in our game. That's stuff you can email about if you're not sure. So the first thing we're going to want to do here is put our background in. Pretty simple stuff. Expand it to this area that is the viewable port for the player. We've got that. It's not a great background, but that's okay. I'm sure you'll come up with something better. And then we probably should go ahead and set our sprite renderer sorting layer to background, so we can just do that right from the very beginning. That way we'll have everything appearing on top of each other properly. So over here, add sorting layer, and then we'll just add the 3 that we're going to use here, which are background, platforms, and player. And I mean, you could just as easily call that objects or what have you, but that's fine. So over here, let's give our background a sorting layer of background. It appears in our drop-down box there now. And then let's bring in a platform for the player to stand in. As you can see, by default, it appears in the back. So let's give it a sorting layer of platforms to bring it forward. Now those are sorted sort of top to bottom. So the ones on top of the list are in the back of the player view, and then the ones at the bottom are in the front. And then finally, let's say, so as for our player, we need to use the sprite editor here. I imported a sprite sheet, so first give it a sprite mode of multiple, and then we'll go sprite editor. We can apply that, and the easiest way to do this is just to do a smart slice. If you know the dimensions here, you should do the grid by cell size, but I don't know them off the top of my head, so I think an automatic slice is fine. You may recall from class that if we do this here, we can see what we need. So slice it. Didn't come through very well. Okay, sometimes this takes a little bit of doing. So let's do a cell size, and I don't know, that's definitely not going to be it, but oh, this thing's huge. I see the problem. Okay. We want something more like this then. Sometimes the slices don't go super great, but let's get this like so. We can just do it manually, or at least get a look at what our numbers need to be. So I've got width of 374, height of 512. All right, we'll go with something like that then. My cell size, or wait, we want the whole box, don't we? Otherwise, it's not going to work the way we want. So something more like this. Okay, so in my case, now yours might be easier than this. If you use Pascal, you're going to have just probably a 32 by 32 or 64 by 64. That makes your life easier. I did not make my life easier here, but that's okay if it takes a little bit of extra time. So I think something like this, and we'll see how it goes. That's 416 by 646, so we'll go 420 by 650-ish just for rounding. 420 by 650. Slice that, and then it auto slices. We probably need to go a little smaller. How about 400 by 600? Actually, 650 might be, yeah, 400 by 600. Let's try that. Okay, that's warmer. I'm not going to need this bottom row anyway. I think I would just need a little bit less height if I were to get all 4 rows and columns. I think 400 was just right. If I go 575, how does it like that? Too big. Sometimes it takes some trial and error here, and that's okay. This is why it's a good idea to make your own sprite sheets rather than grabbing something from online if you can help it. Looks like 600 was just a little bit too small, or too big. Okay, that'll do. We'll go with that then. So we'll apply that, cut. Doing this in black and white mode is really nice for seeing where the sprites are. So that's applied now. We can close the sprite editor, and now we've got all of our, by clicking this arrow, we've got all of our different individual sprites here. I want to use the sideways ones because this is just a simple platformer, so I'll just go with this right here. Obviously, we're going to need to shrink it some, but it's better that it's too big rather than too small. Sorting layer to player. I like the notion of just this giant platformer. That's funny. Better than too big than too small, because then when we shrink it, we're not going to lose any of that nice resolution there. Okay, so now we've got sort of the basic visuals. I can use my wheel bar to zoom in on this thing. We are going to add the following components. We need a collider on the platform. I'll just go box collider 2D because that's nice and simple. You can edit the collider by clicking edit collider and then bring it right down to the edges of this thing. Polygon collider 2D is also an option. That just snaps to the edge of the photos if done correctly. We'll give the player a polygon collider 2D under physics 2D here, or you can just search it. Polygon collider 2D, great. There's a mushroom there. And we also need the player to have a rigid body 2D so that it can be affected by physics forces. We want our rigid body 2D to have a gravity scale of 1. That's the default, so that all works nicely. So I can test this already. If I move my player up a bit and hit play, it should fall in my game view here, and then you can see it fell to the platform, which is just perfect. Okay, so that's what we want here. We'll move them back down to the start here. It's also a good habit to, when you create the objects in your game, to rename them. So over here on the left side in the hierarchy, we'll call this player. We'll call, I think background and platform are probably fine for names there. Okay, now for the player, let's get a quick animation here, just a default animation. Let's get the 4 frames that represent our walking sort of sprites there, and we will just leave it as a default animation for our game today since it's basic. Select the first one, and then you can hold shift and click the last one, and that'll auto select all 4 of them, or you can hold control and click them individually like so. Okay, and then drag those up onto your player. In the hierarchy, you have to do this without the player already selected or it won't work properly. If that happens and you don't get the dialog box for creating a new animation, then just redo it. Okay, so I drop it here. I will call it player walk. And if I hit play now, I should see that animation happening. And it's a little speedy, but it's not bad. And that looks just fine. Okay, so let's go to our animator tab real quick here. If you don't see this tab, you can just go window and then animator is in here. There's the one animation that I made. This popped up when I made an animation. Let's slow it down to something like 0.5, see how that looks. Yeah, that's fine. We'll go with that. Okay, this is very generic Mario sort of thing. Okay, so we've got our animation in place. We've got our player in place. Let's put one more platform in here. Now that the platform is set up the way it needs to be, we'll make a prefab out of this thing. So we can just drag this down onto here, like so. So now we are going to make this, we have this prefab here, so we're just going to drag this up into our scene to give ourselves a couple more platforms. And you can even continue these off the starting screen because we'll take care of camera in just a second. Okay, so just a simple sort of build for these platforms, so we'll be able to move from platform to platform after we set up our code. So that's what we have so far. So now that we have sort of our game area set up here, let's quickly add a script to the player. So select your player and go new script. We'll call it player controller. Remember that you cannot have a space in this name or your code won't work. I like to go, since it's a class that we're creating, definitely make it a capital first letter here. It's appearing on my other screen, but I'll move it over. Yes, I'm multi-monitoring. Okay, so here is our code. As you may recall, start is what runs once, update runs once per frame. It gives us that little comments there to remind us. So what we're going to need here is a reference to that rigid body so that we can apply a force upward when we want to jump. So let's say rigid body 2D. We'll call it RB2D. That's just the default. Reference to rigid body 2D. I just like to have a good sort of base here. And we'll go, we can make it public. We'll say public float speed. If I give it a starting value here, that will be the value when I start the game. But if I only initialize it here instead of in start, then I can change it in my window in Unity. So that's a good way to do things so that you can change it during testing. Okay, so we'll call that speed. In start here, we just want to set up the reference to the rigid body 2D. So RB2D equals get component. Remember, get component is maybe our most important method that we have. And then in update, we want to do left-right movement, and we want to have jumping. Okay, So our left-right movement looks like this. It's just we take the position of the player and manually move it when the player is pushing down a button. So if pressing, we'll use A and D for left and right. A, move left. If pressing, D, move right. So that will be our left-right movement. Pretty simple. So if input.getKey, keycode.A, then we want to do transform.position, and so transform.position refers to the physical position of the player in the world. It's the player because it's this script that it's attached to. So this thing's transform, the position of that we're going to actually subtract from it, and what we're going to subtract is a new vector 3, and that can take 2 arguments. So what we're going to do is we're going to subtract the x position, which is speed, and then we have to sort of normalize that for the frame, so we multiply it by time.delta time. And then the y position is 0 that we're going to change. Okay? And then down here, we can just copy this and change what we need to change. So keycode.d, and we'll add this. Okay? So that's our left-right movement. Control-Shift-S to save all here, and you can hit play, and we should have left and right movement with A and D. Oh, oops. Well, he was a little clumsy, and that's okay. That reminds me of something, by the way. You can see he kind of like hit his face on the other platform there. You probably want to freeze your rotation in on your rigid body 2D for the player. So freeze rotation in Z. You can check that box under constraints. Okay, but that was pretty amusing, so if you want to leave it there, that's entirely your call. Okay, so we should have left and right movement. Gravity is kind of taken care of behind the scenes, and that's the story there. Okay, we're going to go back over here and handle a jump. We're just going to apply an upward force to the rigid body, so if the player presses space, apply an upward force. So if input.getKey down this time, so the moment they press it, that's the frame in which they press it, we'll go, whoops, I need to give that an argument, keycode.space. Then we will say, if they say get key down, then we will apply an upward force, so rb2d.add force. And what we're going to add is a new vector 3, and we'll say 0 in the x direction, and then we need a jumping value, so let's add a variable at the top here. Now this is not the same sort of scale as the speed, so the jump value needs to be a lot bigger because we're actually adding a force, so we need to overcome the weight of this thing. So I'll go with like 200 for now, and we can change that later if we need to. 0 and jump, oops, is my force that I'm adding. Okay, so I save that and test it. It's important to have this thing in a working state all the time, so do your save and testing a lot. And if I hit space, actually that is probably just about what I want. Now the problem that many of you have probably noticed already if you're with me in testing this thing is if we hit space a bunch of times, then we've got ourselves infinite jumping. My guy can fly. That makes a platformer a little less fun, or at least a little less challenging. Maybe it's fun to fly through the screens. Maybe if we put a box at the edge of the stage, but for now, we don't want it to be able to fly. So the best way to handle this is to create a couple of objects beneath the player and test if there's any platform below us. And if there's a platform below us, we're allowed to jump, and if there's not, then we're not. Okay? For that, we're going to need to tag our platforms. So let's go back to our platform. We can do it on the prefab, and the tag is right here beneath the name. We'll go add tag, and we'll just tag it. We can add the platform tag, and that actually creates the platform tag, but to tag it, we need to select it again and grab that in the drop-down box. So platform. Okay? So once we have, so that will be applied to all of our platform objects automatically. You see they all have the tag. That's the advantage, one advantage of using prefabs. So we go back over to this right here, and what we want to do is make sure that we are standing right above a platform. So let's create a couple of child objects of the player. So select your player here. You can right click and go create empty, and we'll do that twice. We'll call this something like platform test 1 and platform test 2. These are just empty game objects. They represent locations in the scene, and they are, if we have these arrows selected, we can just see their positioning right here, or we can do it with this one selected, and we can kind of see the little bubble there. It's not great. I like the arrows better, I think. Okay, so let's say put it right below them here, and then right below them over here. I guess we should put it beneath his feet. That probably makes the most sense. Okay, so platform test 1 and platform test 2 are there and there. So what we're going to do is, from the physics 2D class, it's a method called overlap area. We're going to use these two empty game objects and say, okay, if there's anything in between those two that is tagged as platform, move that up a little bit there, okay, then we're allowed to jump. And if there's not, then we're not allowed to jump. Okay, so that's the way we're going to handle this thing. It's a nice clean way to do our jumping. So let's make references to those. We'll make them public so we can drag them in Unity. We'll say public game object plat test 1, plat test 2. Okay, and then once you do that, save it. And since it's public, we'll see it on the player here, right over here in this area in the lower right. So let's drag those objects in so we have those. We don't want any empty references, or that will cause our program to do weird things. Okay, and then here we'll say if the player presses space, and aren't in the air. Okay, so we make sort of that note there. So what we're going to do here is check whether they're in the air first. I think doing it with a boolean here is going to make our code a little cleaner. So bool can jump equals physics 2D dot overlap area, and then the overlap area is those two game objects that we had. So plat test 1, plat test 2. Okay. Dot tag. I have this right. Dot collider. What are my options here? Oh, I think I need to use position here. Hold on. We'll go full screen with this just so you can see everything at once. The positions of those. Whoops. It wants positions, not objects. So we take the positions of those things, and what are my options here? Dot, yeah, collider. Dot tag. So that's if the tag of that thing we hit is equal to platform. What don't we like here? Okay, so what we actually need to do here is take out the collider portion. That will make things easier. Okay, so we can say if the thing that we hit in that area, which is this, if its tag is platform, then we're allowed to jump. Okay, so that's kind of what's going on here. So if down here at jump, we'll say if that and can jump, then we will be able to jump. So let's save that. Let's go back to Unity and let's test this thing out. Nope, no good. We got problems. Okay, so my problem was my platform test 1 was a little too high and it was hitting the collider of the player. So put this in the area below the player so that it covers just this little space here. It uses those two game objects as corners for a box, and it checks that box. If you hit your own collider, then you have a problem. Now there is a way to check all the colliders in an area, but that's a little more complicated than I want to go today. This is just a basic thing. So now it is working, and if I try to hit space a bunch of times, it does not let me jump. I maybe made it go a little too low because it is letting me jump a little below the thing, but it's not going to break it for us, so we'll go with that. Okay, the next thing we want to do here is have the camera follow the player. So on your camera, let's make a script. Oh, no, wait, hold on, no reference exception. Oh, right, it's saying that when it doesn't find something. Okay, that's probably not going to create a problem for us. To fix that, I might add a check to see if that collider exists before running the test, but it's not strictly necessary. All right, let's add a new script to our camera. Call it camera controller. And we want this thing to follow the player. So camera controller, double click it here to open it up. If you ever see that, just hit reload here. And so we need a reference to the player here, which is a game object. We'll call it player. This time, instead of dragging in the reference in Unity, we'll just do a find inside the code. Here we'll say player equals game object dot find, and this is why it was valuable to have standardized naming, because I can use this line of code a lot of different times. Okay. We also need a distance between the camera and the player at start, because we want to maintain that distance. So we'll say vector 3 offset, we'll call it. This is distance between player and camera. So the way that we set this up when the program starts is we use a little bit of basic algebra here. So we'll say player or camera position. No, we want to set the offset, sorry. Offset equals, and we'll call it, I guess, player position minus camera position. It doesn't matter if you go the other way with it, you just have to go the other way in your update method. So what that code looks like here is offset equals player.transform.position. It's very close to what I just wrote, actually, minus transform.position, because transform, if I just use transform, it refers to the transform of this thing the code is attached to. So in update, we want to rearrange my algebra here and say camera position equals player position minus offset. So if you can look at sort of this line and see how algebraically they're the same thing, just rearranging variables here, then it'll become pretty clear. And that's actually, I'll write that code, so transform.position, just rearranging what's in the line up above, equals player.transform.position minus offset, and save that. Go back over to Unity, and we should have the camera following the player now if we did that correctly. All right, looking good. Except that the background is acting a little wonky, so probably a good idea to make the background a child of the camera. So you can just do that right here, just drag it onto there. And okay. Now we have sort of a basic, simple platformer. All right. Our next step here would be to add things like pickups, perhaps enemies, maybe any of the other, a projectile, any of the other stuff we want to do. But I think this is a good starter for getting this thing moving around and just getting the basic mechanics in place. So if you would like to just put a whole bunch of platforms in here and get movement tweaked to the way that you would like it, get your basic animation looking the way that you would like it, I think that is good for now. And we'll continue this in the next lesson. Thanks.